This is number 3 from the target round for the 2015 Sycamore Invitational. And when you first read it, this problem, it feels a little intimidating because finding 3-digit prime numbers is difficult. And there's a lot of them, and it's hard to know if a 3-digit number is prime. And so this problem seems really hard until you recognize that any pair of 3-digit numbers, three consecutive numbers, 3, 2, 4, 5, 6, 7, 6, 7, 8, any of these that you could come up with result in a sum of the digits that is a multiple of 3. No matter what, if you take 3 consecutive numbers and you add them together, 3, 2, 4, 5, 6, 7, 6, 7, 8, any of them, you get a multiple of 3, and by divisibility rules, that means that number is divisible by 3. So that means there's no way to create a 3-digit number that is prime and has 3 consecutive digits. So we can ignore 3-digit numbers altogether. So then it's just a matter of knowing your prime numbers well. 12 and 21, neither one of those are primes. 23 and 32, well, clearly 32 is not, since it's even. So 23 is a prime number, and so that's one you should just know as a prime number. We notice that we don't even need to think about the evens, and so when we do 3, 4, we only have to consider 43, and 43 does work out to be a prime number. Obviously, when we do 45, that is not a prime number because it's divisible by 5. Same thing with 65. 65 is not a prime number because it's divisible by 5. So then we get into 67. 67 is a prime number. 87 is not a prime number because 8 plus 7 is 15, so 87 is divisible by 3. 89, however, when you use the consecutive number with 9, is a prime number. And so the 4 prime numbers that have consecutive digits are 23, 43, 67, and 89. So 4 numbers. So there are 4 numbers that fit this criteria. It did seem harder than it actually was, but it turned out you only needed to check a few numbers and see whether they're prime. And with a calculator, that's a very easy and doable thing if you don't know your prime numbers. And so those are the 4 that you find.